This podcast is designed to help you with homework problem number 7. Homework problem number 7 states that we want to consider the following thermochemical equation where we have 2 moles of solid sodium plus chlorine gas, which yields 2 moles of sodium chloride solid. The delta H change in enthalpy for the reaction is negative 821.8 kilojoules. You're asked to first determine if the reaction is exothermic or endothermic, and followed by that you have to calculate the amount of heat transferred when 8.0 grams of sodium metal or solid sodium reacts according to the reaction at constant pressure. So for 7a, as noted on the homework answer key, the answer is exothermic because the delta H value for the reaction is negative. So once we continue on with 7b, where you have to actually calculate the amount of heat transferred when 8.0 grams of sodium metal reacts according to the reaction at the pressure, let's begin the process of figuring out this equation by writing our givens. So what do we know? We know that we have 8 grams of sodium metal, and we know the enthalpy change is negative 821 kilojoules per mole. Typically, when we have delta H values, the kilojoules per mole concept, it relates to certain elements or compounds in the equation. It's important that you recall that because, as stated before, in 111, when you learned about stiochiometry, typically when you see a chemical reaction given, stiochiometry will have to be applied in a certain way. So you have to always keep that in mind, which is why some of this may have confused you. So let's continue with the problem. And the problem is asking us to find Q, the amount of heat that is transferred when this 8 grams of sodium reacts. So how do we proceed? We have to figure out our conceptual plan where we know we are given our grams. From grams, we have to go to moles. So how do you go from grams to moles? And lastly, we have to find the amount of heat that was transferred, which will be in a unit of energy. In this particular case, we would keep it as the same unit as our delta H, which would be kilojoules. So what other relationships can we form from this reaction here? Well, we can now see that what we have are the relationships from the chemical equation are that we have 2 moles of sodium that equals negative 821.8 kilojoules from the change in enthalpy. This again comes from the stiochiometric relationship in the problem. Furthermore, we can also determine from the givens in the equation that we can just use the periodic table to determine the molar mass of the sodium metal as well. So these are good starting points to help you figure out how to proceed with the problem. Again, you have to start thinking linearly, and remember, it's all about the units because this is when that slogan really comes into play. So let's start by trying to find a solution by implementing the conceptual plan where we start with grams, we move from grams to moles, and then we solve for kilojoules. And what we can do is we can write our 8 grams. We can then invert our molar mass where we have 22.9 grams per mole. And lastly, we substitute in or write in our delta H value, which is negative 821.8 kilojoules per mole. Keeping in mind that it's all about our units and our units need to cancel out. With this happening, our final answer will come up to be around 143 kilojoules per mole, but we can round that to 1.4 times 10 to the second kilojoules. Now, the key thing here to keep in mind about when we solve this problem is, again, it's important that you keep the context clues in mind for these thermochemical equations. That simply means that you have to remember, these are just like word problems in math class. where we're talking about the amount of heat transferred. So we're transferring heat from somewhere. So the sign of just a heat transfer would not apply in this particular case, hence the reason we left the negative 821 off. If we wanted to calculate the change in enthalpy, the sign would be relevant at this point, but it is not used because we're looking at specifically Q, the heat transferred. For 7b, we will now look at calculating how many grams of sodium chloride solid are produced during an enthalpy change of 10.0 kilojoules. Keep in mind, now the givens for part C have changed. So now we have 10.0 kilojoules. Keeping in mind that the delta H for the overall reaction is noted to be negative 821.8 kilojoules per mole. We're asked to find the grams of sodium chloride produced. The conceptual plan we should follow should be the one where, since we know our givens start off with kilojoules, we take kilojoules, we go from kilojoules to moles, and then moles to grams. The relationships we can note are basically coming from the balanced chemical equation that was given to us, where we can determine that if we have 2 moles of sodium chloride, that would be equal to 821.8 kilojoules, and we can also determine, again from the periodic table, the molar mass of sodium chloride, which would be 58.44 grams per mole. Now we simply need to implement the conceptual plan, where we take kilojoules that we're given, which is 10. We multiply that by inverting our relationship of 821.8 kilojoules per 2 moles of sodium chloride. And lastly, we multiply that by the molar mass of sodium chloride, which ultimately would give us 1.42 grams of sodium chloride produced. Your unit should also cancel out, with kilojoules, moles, leaving grams on top, leaving the final answer in grams. For problem 7c, we now are asked to calculate how many kilojoules of heat are absorbed when 25.0 grams of sodium chloride is decomposed into sodium, metal, and chlorine gas at constant pressure. Now, again, I must reiterate and strongly emphasize how important it is to make sure that you follow the context clues. These are critical in solving these problems. Looking at what we're given, we know that we have 25 grams of sodium chloride, and that, again, the delta H, the change in enthalpy value, is negative 821.8 kilojoules, given for the reaction pertaining to sodium metal plus chlorine gas, which produces 2 moles of sodium chloride. So we know that that's what has been given to us. However, we're asked to find kJ of heat absorbed when 25 grams of sodium chloride is decomposed. So what is that telling us? We basically have to look at the chemical reaction in the reverse direction, the decomposition of things. And what we've noted about delta H, or enthalpy, is that these state functions, whatever we do to one particular thing, we have to do to the other. So with that being said, there's a change that occurs between each one depending on what we do to the equation. So for the conceptual plan, we need to start with solving, starting with our given, starting at grams, going from grams to moles to kilojoules, looking at the relationships that we now have to form. The problem tells us that the sodium chloride is now being decomposed, so we have to reverse the equation, which allows us to reverse the overall enthalpy change to relating 2 moles of sodium chloride to positive 821.8 kilojoules per mole. And also, we also determined from the previous problem that the molar mass is 58.44 grams per mole. So to solve this, how we would implement this would basically be to start off with 25 grams per mole, divide that by the molar mass, and then multiply this by 821.8 kilojoules over 2 moles, relating that again to the sodium chloride, and we would now calculate this to be 176 kilojoules being absorbed from the decomposition reaction. All units cancel out. Keep it in mind we did reverse that equation, and which reversed the delta H sign due to the decomposition reaction. So this concludes working over problem 7 from homework of the thermochemical equations.